So after my recent video which was about shift register, I decided to make the smallest home automation project, and to make the smallest home automation project I need to choose the small component. So for the controller part, I chose the ESP01 microcontroller board because that's the smallest board with built-in Wi-Fi in it. For the power supply, I stick with the High-Link power supply only because I don't want to compromise the power supply, so I didn't change it because High-Link is the most reliable power supply that I have ever used. So now the next big component in the home automation project is the relay. Now here we can go for SSR like the solid state relay of course, but there are two negative points of it. First being it is quite costly than the regular relay, like it is 5 times costlier as compared to the regular relay. Second point is the SSR which comes in a smaller size can handle current up to only 2 amperes, which is also decent enough, but it is quite low as compared to the regular relays. So because of these two reasons I neglected SSR as of now, but I'll be using it in some other project. But let's just stick with the relays. So I started my research about some miniature power relays by opening the home automation products laying around in my studio, and also I searched for some miniature relays online on different websites. So here in this video I'll be introducing you with some really small miniature power relays, and I'll let you know how to choose a relay wisely for your projects and products, like how to read their data sheet, which contact material they are using, which contact material is better resistive to arc erosions and welding, what is mechanical endurance, what is electrical endurance, and there are a lot of informative stuff I'll be letting you know about the relay which I'm sure you are not at all aware about till now. So now before starting this video, if you are watching me for the very first time, well, consider subscribing this channel because I come up with these kind of educational content in the field of IoT, automation and electronics. That being said, let's get started with our research about relays. बहुत कुछ नया जानने को और सीखने को मिलेगा for sure. Let's get started. Do you know what most electronic companies have something in common? Well, it's the tool that they use for making their products, and the most commonly used tool that almost all the big electronic companies uses is the LTM PCB designer software. Using LTM, you can definitely level up your PCB designing skills and make something really professional out of it. And now, along with the integration of Octopart, searching for any electronic components globally becomes really very easy. Octopart is kind of Google for just electronic components, where you can search for any electronic parts and get that information all on one single web page. So do check out this amazing search engine made just for electronic components. I'll leave the link for this down in the description. Do check it out. So first I opened a couple of home automation products laying around in my studio, out of which one was the Sonoff mini product and other was the Sonoff i-03 product. I noted their relay number and got their datasheet printed. After that, I also searched for a couple of miniature relays online and got a couple of them delivered at my studio. And as usual, I printed their data sheets as well. So as of this video, we have these different miniature relays with us, including a regular sugar cube relay. So let's first try to understand a couple of parameters from its datasheet and observe it carefully. So our regular relay uses silver cadmium oxide as the contact material, which is the most commonly used contact material in the relay, which is commonly used to drive the load from 5 ampere to 50 ampere. Now for those who don't know what a contact material actually is, then the contact material is the material used inside the relay at the output section to make the contact between the pole and the NO-NC pin. It's really important to know about that material because those materials will decide how resistive the contact of the relay is to get welded. Yes, those contacts may get welded while switching the appliances. Now if you are using the relay from quite a long time as of now, you must have experienced this at least once. So what happens is when we are switching the high power appliances, there are arcs generated at the contact part, and those arcs can weld both the pole and the NO-NC pin together, making the relay of no use. And this material called a silver cadmium oxide is more likely to get welded, and also it is very toxic and harmful to the environment, so it is also banned in couple of regions. But still we are using these relays As I said, it's cheap and hence it is commonly used in most of the relays that you have used till now. Secondly, in the datasheet, one important thing to notice is the life cycle or endurance of the relay. Now let me first discuss what is the life cycle or endurance of the relay. So there are basically two types of endurance: mechanical endurance and electrical endurance. Mechanical endurance represent the number of operations that relay can perform with no load attached to the relay. Now if we look at the datasheet, then a regular relay can perform up to 10 million operations when there is no load attached with it. And now the electrical endurance means the number of operations a relay can perform with the defined conditions of load. And again, if we look at the datasheet, then a regular relay can switch up to 1 lakh time when connected with a load of 7 ampere at 250 volt or 10 ampere at 120 volt AC, which is quite a good number. So this number depends upon the material used in the architecture of the relay, like the spring, the contact material, armature, etc. And we get all this thing with a dimension of 19 by 15.5 by 15.5 mm. So those were the important points and specifications of a regular relay that we are using as of now. Now let's compare it with the other relays and see the difference. So the one which is used in Sonoff Mini was almost the same in dimension as the previous one and also uses the same contact material in it and also has the same mechanical and electrical endurance but have higher capacity for the output current. So this relay can handle a load that consumes 10 ampere at 250 volt AC or 15 ampere at 120 volt AC. So that was an amazing number. Then the next product was the Sonoff IFAN-03, which uses the relay which was smaller in dimension as compared to the previous one but still able to handle the load that consumes 10 ampere at 250 volt AC. Now here the mechanical endurance is same, which is 10 million operations, but the electrical endurance is different. And also one thing to notice here is that the electrical endurance changes based upon the load we are attaching. If we attach a low power load, the number of operations increases, and if we attach a high power load, the number of operations decreases, which is clearly mentioned in the datasheet as well. So if we attach a load that consumes 3 ampere at 250 volt, then we can expect 1 lakh operations, which reduces to 50,000 when we attach a load that consumes 10 ampere at 250 volt AC. So one thing is clear, attaching a load with a lower power consumption increases the life cycle, or we can say electrical endurance of any relay. Not only that, the big change in this relay is the contact material used in it. So it uses silver tin oxide as the contact material, which is resistive to arc erosion and welding. So if we use a relay with the silver tin oxide contact material, there are less chances for the contacts getting welded with each other as compared to the one which has silver cadmium oxide in it. Also, silver tin oxide is a bit expensive, so that increases the overall cost of the relay. But I'll recommend to go for the relay which uses the contact material either silver tin oxide or silver nickel for a better and reliable performance. Now these relays are not at all easily available in the local market here in India. So I started my research for miniature power relays which are easily available here in India. So let us start with the first relay, which is HF46F, which is even smaller in size as compared to all the other relays we have discussed so far. And also this is based on silver tin oxide contact material, so that's an amazing point. Then also it can handle the load up to 10 ampere at 250 volt AC. Now talking about its life cycle, then its mechanical endurance is a bit less, which is 5 million cycles, and as we have discussed, the electrical endurance is different at different loads. So the life cycle of this relay is 60,000 operations with a load of 7 ampere at 250 volt AC, and we can expect a life cycle of around 1 lakh operations with a load attached that consumes 5 ampere at 250 volt AC, which is decent enough. And this relay is easily available in India at a price of around 45 rupees, which is 5 times costlier than the regular relay, but comes at a very small form factor and also has a better material than the regular relay. Sahi cheez hai na? And hey, we want to see more smaller relay than the one discussed right now? Well, I'll definitely show you that, but before that, do click the like button and let me and YouTube algorithm know that this video is really great and worth watching. Okay, so done with that. So now let's move ahead with the next relay, which is HF32FA, which is even smaller in size than the previous one, and it's based on silver nickel contact material, which is environmental friendly and also resistive to arc erosion and welding. But this relay has low current rating, means it can handle maximum load of only 5 ampere at 250 volt AC. So that's the point to take care about. And if we talk about the life cycle of this relay, then its mechanical endurance is 1 million operations and electrical endurance is around 1 lakh operations at the maximum load of 5 ampere at 250 volt AC. And this relay cost us around 53 rupees here in India, but this one has a 9 volt coil voltage. I didn't find any particular relay in this series that works on a 5 volt coil voltage. I think it will be costlier than this, of course. Well, anyways, let us move on to the last relay of this video, which is the smallest of all the relays that we have discussed right now. And that relay is HF49FD, which is based on silver tin oxide contact material and has maximum switching current up to 5 ampere. Its mechanical endurance is better than the previous one, which is 20 million operations, but the electrical endurance is bit less, which is 50,000 operations at max load of 5 ampere at 250 volt AC. But it is the costliest of all the relays that we have discussed in this video, and this will cost you around 100 rupees here in India. So those were a couple of miniature power relays, and I discussed almost all the important parameters to be considered before getting one relay for your project or product. Well, now comes the question that which relay I'll be using for my upcoming project. So well, I'll be going for the HF46F Relay, and the reason being, first of all, its size. So size of this relay is almost half of that of the regular sugar cube relay if we consider the width of the relay. So technically we can fit 2 of the relay in place of 1 sugar cube relay, so that's a lot of space saving in our PCB. Second reason being, even if the size of this relay is small, it can still control the load that consumes 10 amperes at 250 volt AC, which is amazing. And the third reason being, we can easily get a life cycle of around 1 lakh operations if we connect a load that consumes 5 ampere at 250 volt AC, and if we connect a lower power consumption appliances, the life cycle will even increase over 1 lakhs, which is a good number. So due to these all reasons, I'll be using it for my upcoming project, which will be the smallest home automation project that I have ever made. So do subscribe this channel right now if you don't want to miss that upcoming project, which will be coming up soon, maybe next week. I can't say anything, but yeah, you can follow us on Instagram to stay updated with all our recent or upcoming projects. So yeah, that was all about the miniature power relays. Well, do share your thoughts about, was this video useful, or at least you got to learn something new from it or not? Do let me know your thoughts down in the comments of the video. Also, you can share your views about what are the important parameters to be considered before having a relay, if I missed anything. So you can share your thoughts or useful information down in the comments of the video. So yeah, that was it about this video, and I am just ending this video here and now. Just wait for my next video, then explore, learn, share with me, techiesms.